Hi all, today we are re-implementing a clone of the cat command. Cat, it's not the cat as in cat, but it's standing for, it's not the cat, it's standing for concatenate. Wow. Okay, so we are re-implementing the cat command. It's a Linux utility to concatenate files and print them on the standard output, or if no files are provided, they will just copy the standard input to the standard output. What cat is doing in practice is taking from standard input something, hello world, and then we feed that into cat, and then it outputs hello world. So it's writing standard input to standard output. What's the use of that? Probably there's not much use in that right here. But it's also used for concatenating files, such as when you have a first file. This is the first text inside the first file. And then you have a second file. And this is the second file. And if we now call cat with the first and the second, then it will print out the first file, concatenate it with the second file. So it will print all of those inputs to standard outputs. And this is used in practice to concatenate both of those files and redirect them into a concatenated result, which then contains all the inputs. So if you want to concatenate files, that's what it's used for. If you just want to print a file's contents to the console, this is also a good use of cat. So you can do cat concatenated, and it prints all of the file's contents to standard out. Okay, to implement this in C, we're going to have to use something that reads from standard input or from files. To do that, we're going to use a method called getC to get characters. So it's reading it's reading characters from a file. And if no file is specified, then we can just replace this file stream with the standard input stream. And actually it should not be that hard. So let's just jump right in and create our own cat.c file. Let's include the standard library stan.io for handling the streams. And let's create a main method. And let's write. Okay, now I have to think for a second. We are reading characters from the console, from standard in. So we do while c equals getC from either standard in or from a file. Let's just do standard in for now. And then we write the results to the console. So probably we can just do put C, and then I don't know if we have to specify the standard output here. And then we also check if C is not end of file. So if it's end of file, this while loop terminates. And then we return a return code 0 for a success. What's the error here? Why is this showing an error? I have missed a parenthesis somewhere here. Okay, now if I look up the documentation for putC or for getC, yeah, this is reading a character from a stream. There's also fgetC. What is the difference between those two? getC is equivalent to fgetC, except that it may be implemented as a macro. Okay, we don't care about that. And we can also use getCharacter, which will only read the characters from standard in. So let's search for that. That would also be sufficient for many uses, but we want to write an actual clone of cat, so we have to read from file streams. Okay, so we are getting characters from standard in. Let's just look up the documentation again. getC. getC reads from a file stream. getC. Let's search for some information here. And it's the same as fgetC. It reads the next character from stream and returns it as an unsigned character cast to an int or end of file. And that's why we're checking for end of file here. And then it's putting that to standard output. We just want to read from a file descriptor. And the file descriptor is this. And we can open any file using fopen and then specify a path here. And here we just take what is provided as an input argument, argv at an index. And for now, let's just handle one file, one input file. So we are going to get argv at index 0. To do that, we have to extend the main method with an argument count and a constant character pointer argv array of unspecified length. And that should be it. Now something is not working. I don't know why. Too few arguments. We of course have to also specify that we want to read the file only in read-only mode. We don't care about writing to the file. So we need to specify the R character here for read-only mode. Now there's still a warning here about an incompatible integer to something pointer conversion. We can check out this warning in this shell right here. So let's go to the cat directory and let's gcc, let's compile the cat.c program here. Output is cat. And let's also enable all warnings and debug flags just in case we're needing it. We need them. And fopen doesn't expect the character here, apparently. So I'm misusing the function. The first argument is the file name, that's fine. What is the other argument? It's the first one is the path name and the second one is the character, constant character mode. So this is not a character that we input to the fopen function, but it's a string. And this should fix it. And now it's fixed. We are reading a file. Let's replace getC with fgetC just to have fopen and getC aligned. But it doesn't matter in practice. Now we are reading something from the file and then putting it to standard output. Now there's just one thing that I want to handle, and that is if the file can't be read, then we probably need to null check it. Yeah. Upon successful completion, fopen and the other methods return a file pointer, otherwise null is returned. So we can check here if the file pointer is equal to null, then we terminate the application with a negative or a non-zero exit code. And those are declared, I think, in standard lib. Yes. Okay. So let's compile. And it compiled. And now let's execute cut. And that's crazy. That's crazy. I hope there's no sensitive information here. I just specified that I want to execute cut without arguments. So what it did here is it still expected arguments because it didn't check for the provided argument count, and then it accessed the memory at this location right here at argv0 and just dumped that to the console. That means I just accidentally accessed memory that I didn't want to dump here. So this is some of my private memory. Please respect the privacy here. Yeah, so we have to fix that. That's a nice error. I like that. So of course we also have to check the provided character count. If argc is null, then the file descriptor that we're using, so file descriptor is declared here. If we provide no input arguments, then the file descriptor that we're using is standard in. Else we have to use fopen. I don't know if that syntax even works. I don't think so, honestly. Let's try to compile it, and it seems to work. Can I just execute cat now? No, it's still dumping something to the console, of course. No, let's put the curly braces here as they are expected. So if, else, like so. So if we provide no characters and no input arguments, then we are reading from standard input, else we are accessing, at least in this first iteration, the first file that is provided in read-only mode. Okay. And now, of course, I have to compile that and execute cat, and it's still dumping my memory. Why is it still dumping? What am I doing here? Ah, no, the argument count is not 0. It is the argument count is at least 1 because the first argument is the name of the executable itself. So it must be, if it's smaller than or equal to 1, then we're reading from standard in. So let's try again. Okay, and now we have our cat clone active. Let's write something, test, and it's outputting test to standard int, to standard out, I mean. Standard out. Yeah, and that's exactly the same behavior as regular cat. So if I type cat, which is accessing the regular cat command from user bin cat, then it's doing exactly the same thing as you can see here, standard out. So it's just duplicating whatever I feed it. So that's working fine. And now we can also try to call our own cat with an input file. So let's call it with the first input file, and it's dumping stuff to the console again. My privacy is violated. So why is it doing that? I'm trying to fopen, I need to fopen argv1 because 0 is the name of the executable. So let's try again. Oops, tmux attach, there we go. So let's compile again and execute cat without arguments first, second, third, that works. Or we can execute cat with a file. And now it dumps to the terminal the content of the file. So this is already looking quite cat-like. The only thing that's missing now is that we have to be able to concatenate all the files that are input. To do that, we have to, depending on the argument count, loop over or open multiple files, I would say, and dump them to the console I'm just thinking how to properly do it. Should we wrap it in a for loop, or should we have a while loop? It doesn't really matter, probably. So let's do the following. If the argument count is smaller than or equal to 1, then we're reading from standard input, which is still valid. Else we are reading from the provided files. The provided files are opened here. This is not as trivial as I thought, because what I'm thinking right now is that, let me show you in Paint. We have this constant character pointer argv, so this array of strings, but the first string can have this length, the second string can have this length, the third one can have this length. So we can't really I was thinking how to store that, but okay, actually it's already stored here. I don't need to worry about that. Maybe my thinking was flawed right now. Basically what I have to do is I have to initialize an array of file descriptors, I would say. An array of file descriptors with argc, with a count of argc, which is the number of files to be opened or file streams to be opened. Then if the argument count is smaller or equal to 1, then the 0th element will be set to standard in. Else it will be set at an index. So we have to loop here for int I is equal to 0, I smaller than argc, I plus plus. Then something happens here and we assign the file descriptors at index I, this value right here, and we have to access argv at I plus 1 because we always have to read. Yeah, we have to read I plus 1. Then I'm just thinking, yeah, the argument count is, for example, let's say we concatenate 10 files. Then argument v will still have 11 entries, I think, because the first entry will be the name of the executable itself. So I think argc and argv don't match in size. We can check that later in the debugger if it's necessary, but let's just try that. And now we can check if a file descriptor is not accessible. Then we exit. I only want to concatenate files if I can open all of them, else we will return with an exit code. And then now we have the array of file descriptors open. Now we can just loop over all the file descriptors and put them or print them to the console. So again, let's loop. Starting from index I is equal to 0, I smaller than argument count. And that should be almost it. There's just this one fd access here, which I have to address with an index. And that might be it. That would be my first guess at how to concatenate files. So let's scroll down a couple of lines. This is almost the full implementation here, all visible on the screen. So let's compile it. It works. The compilation works. Let's execute cat with first and second. and it doesn't do anything. So this doesn't work. If I execute cat with only second, it doesn't do anything. And if I pipe something, some message into cat, does it do anything? It does something. So we have now the chance to debug this. So let's go on a new tab here, a new window. Let's cd into cat. And let's call the debugger GDB and provide cat. Okay, and now we can do layout next and shift to the source code view and put a breakpoint in, well, I was setting arguments to first and second, so we have to do that here as well. Set first and second. So those are the file names that we want to concatenate. Set args first, second. Now that should be set. And what we just observed was that from the standard input, if we don't provide any arguments, the files are being printed to standard out. But if we specify files, then they are not printed to standard out. So let's try to put a breakpoint in line 23, break 23, and let's run the program. And now, as you can see, the program exited with an error code. That means we didn't even reach this line in the code. So probably we should set a breakpoint earlier than that. I will set one at line 7. So break 7, run. Now we are at line 7, as you can see, and argument count, print arg c, is 3. Now if we hit next, then we are in the else statement. And here we are looping over integers I starting from 0 up to 3. Exclusive, so it's just up to 2, as far as I understand. So let's open the first file, specified at argv I+1. I is currently 0. Yes. And argv is, how do I print it? I think I have to dereference it like this. This is the first index of argv. Well, the 0th actually. And if I do this, no. Wait, print argv, and then I think I can do at 3 because I expect 3 entries in argv. Yeah, it has 3 entries here, which are 3 addresses, and I can then dereference them and get the contents, as you can see. Yes. So this is argv. The first one is the file name that we are executing, then first and then second. So let's try and see if it can open the file specified in I+1. And I can already tell, since we are looping up to argc, then this will overflow. Or it will access an index out of bounds. So we were open to open the file descriptor. So let's print the fd at 0. And it's done. And let's try again. And now it should be failing because I is now 2 and it's trying to access argv at index 3, which doesn't exist. Because if we do print argv at 4, so 4 entries, that would correspond to index 3, then this index is not accessible. So let's hit next. And now the file descriptor at this index is probably, is it null? Yes. And now here we exit. So probably we could have made our lives easier by putting a print statement here, printf, invalid file provided, and then we would be wondering what file is invalid. At index I equals, but we didn't provide an invalid file. We would just know which index failed, and then that would have saved us. I plus 1. All right. And now what we have to do is we have to loop from I equals 0 to argc minus 1. And that's it. Let's see. I expect this to work now. So let's gcc compile again. And there's an error. There's a warning. If clause does not guard, of course I have to put the curly braces here, otherwise they wouldn't wrap those statements here. So again, let's try to compile and let's test our application and see what it does. Let's call cat. It expects no input from standard in. First, second, third, fourth. It's all duplicated, which means that it works. And we can also echo something, some message into cat. This is the original cat. I have to call my cat, which is in the local directory. And it's echoing that to standard output. And if we call our cat clone with input files, first and second, then they are concatenated and output to the console. We can of course even specify multiple files here. Let's see if that works. This is a segmentation fault, and I would be wondering about why that happens. Maybe because we are trying to open a file multiple times. I don't know. Let's jump into the debugger. Let's quit this. Let's gdb cat. Layout next. Next. And let's run. And I think there's some way to catch segmentation faults. I've written it down at some point in my magic little notebook. But where is it? Wait. My magic little notebook. I will find it in a second. Yes, we have to write back. Well, first of all, we have to set arguments, set args. First, ideally we have to set the same arguments as those here. Then we can run this. Oh, it's seg faulted. But did it break at that location? No, it terminated GDB even. So let's run this again. And I will show you in a second how to halt at seg faults. So we have to set args first, and then we have to write backtrace full normally. And actually that was my understanding. I don't know why it says no stack. Let's try to run this, and it complains again. But this segmentation fault is happening at line 37. So what is in line 37? Let me activate the line numbers here, set number, and let's jump to line 37, which is this line down here. Oh, great. Why is it seg faulting at line 37? That can't be. I was probably misunderstanding the error message. No. Let me just open my browser here and look up GDB stop at segmentation fault. Now we can use run, seg fault happens, and then backtrace. Aha! Can we do backtrace here? No, we can't because the application is still... Oh, it's running now? No. Again, layout, next, source code, set args, run, and now backtrace. And here we can see that the following lines are responsible. And can we now print the contents of some variables here? That would be very useful. Wait, backtrace full. Okay, variable I has a value of 5. 1, 2, 3, 4, 5. Which I is it even? It's in line 28. Line 28 is this one. This doesn't make sense. Oh, what are we doing here? So we are getting file descriptors according to the variable count, which doesn't make sense. I think I have to loop over argc until argc-1 here as well, because the argument count is not the count of provided files. It's always argc-1. Okay, and that should be it. Now it should be working. Let's go to the compiler. And it was quite nice to figure out the... Wait, did I just exit tmux? Yes, I did. Tmux A. It was quite nice to figure out the stack, the segmentation fault with GDB, and by just writing backtrace full. It's quite convenient, and it can even print the state of the variables at right when the segmentation fault happened. That's very, very powerful. Okay, so let's cat again. No, let's compile again. GCC, and let's cat. Doesn't work. Why doesn't it work? If the argument count is 0. No, wait. I think the -1 might not be the cause. The argument count is just the count of provided arguments, so that should be correct. And it should always be at least 1. So what are the other variables here? The last file descriptor has the value 0xd, which is definitely wrong. So I think we failed right here. We have 1, 2, 3, 4, 5, 6 files. How is that possible? 1, 2, 3, 4, 5, 6. Oh my god. But I'm specifying just 5 input files. I'm initializing them according to the argument count here. And I have no. Does that mean that the argc variable, where's the argc variable here? It's not printed. There it is. Is 6? Why is it 6? we provide 1, 2, 3, 4, 5 arguments. Okay, that means my understanding of argc was wrong. Argc is 6. That means we have to go up to argc minus 1 here. But that doesn't work if we only have the standard input file descriptor. Well, if we don't specify any inputs files, then the argc will be 1. That means we have an array that can hold 1 element. And then we set the first one to standard in. And that means we loop from 0 to argc minus 1. Yeah, that should be fine. So why is it not working? I have to check in GDB and run the executable without any arguments. So let's layout next. And let's put a breakpoint in line 26 and let's run. And let's hit next. And it jumped right over that. And that's the issue. Why does it jump right over? Print argc. Let's print argc. Argc is 1. And 1 minus 1 is, of course, 0. That means 0 is not smaller than... Oh, God. We have the problem at accessing the first file descriptor here. So how do we do it properly? Int I is equal to 0. Argc well, we could just do this. But this doesn't make sense for the upper limit. Huh? Something is broken in my understanding. If we have 0 input files, then argc... Wait, if we have 0 input files, then we have... then we create a file descriptor manually, but we have no arguments that correspond to it. That might make sense. Yeah. So we can solve this simply by doing the following. We just print out concatenated files if we have files as input. If we don't, we can just handle for the standard in separately here without the for loop, just putting standard in to the standard out like this, accessing just file descriptor at index 0. Okay, so now if we are reading from standard in, then it will put the characters from standard in to standard out. And if we have provided files, then it will print those files individually, looping over the file descriptors to standard out. But it's separate from the standard in handling. And this should be our implementation of cat. Yeah, so let's assume this works. And let's do a final test. And I strongly suppose this works now. So let's go here and do the compilation command. We have no warnings, nothing, which is a good indicator. If we do cat now, then it's expecting inputs. second line, and it's duplicating them, so that works. Then we can terminate the input using Control D, which is also the case in the original cat. Then we can echo something, message here, into cat, and it will print that out to the standard output. Great. Same behavior as the original cat. Oh no, I have to make sure to call my cat and not the original one. Yeah, same behavior. And now, as a last master test, we have to provide our input arguments here, which previously failed. Now I'm expecting multiple concatenations of the first, second, and second file again, all printed to standard out. And that's it. Here's the first file, this is the second file, this is the first file again, and the second again. So this is a way to concatenate an arbitrary number of files, I think up to the maximum number an int can hold. But in practice, it's an arbitrary number. And I hope you enjoyed this video. This is a cat clone. If you did, please stick around, leave a like, and see you next time. I will, by the way, also upload this code to my Patreon. You can become a Patreon. I will give you access to a private repository where you can get the code for all projects that we code on this YouTube channel. All right, and see you next time. Bye.